Back in 2019, a mysterious comet from a faraway star system whizzed by Earth. At first glance, the visitor named 2I Borisov seemed to be rather ordinary, but studies since have revealed signs that it is far from an average comet. Now, two research studies released in March 2021 have shed new light on our visitor and helped unveil information about our own solar system. When Borisov was first sighted by an amateur astronomer, initial data suggested it was a typical comet, meaning it was made of things like ice, dust, and gassy materials that researchers had all seen before in our solar system. Soon after its finding, NASA's Scout system at JPL automatically identified the comet as a potential interstellar object. This software alerted astronomers across the world, and they quickly pointed their instruments toward Borisov to learn more. And what exactly were those astronomers looking for in this alien comet? In order to study a comet, astronomers take a look at the particles being expelled from the comet's surface. In fact, you're probably most familiar with images showing a comet shedding their outermost layer and what's known as a comet. The comet forms when the comet passes close to their host star and are bombarded by heat and radiation. Dust and debris break off from the comet's main body, and ice sublimates into gas. And by studying the released particles, observers are able to make educated guesses about the composition and the history of the comet. Previous studies found that Borisov likely contains between 9 and 26 times more carbon monoxide than other comets we've seen before, meaning that Borisov probably formed in extremely cold temperatures around negative 250 degrees Celsius. And these latest studies have built upon this conclusion to provide additional evidence of the comet's alien nature. Using different methodologies, two recent studies took a closer look at Borisov's comet. The first from ARMA Observatory and Planetarium measured the reflected light of the comet. As the light from the sun scatters through the particles, astronomers are able to determine size, composition, and shape based on the electromagnetic waves. The team concluded that the observed light was being reflected through extremely small particles, suggesting that the comet is close to its original form. This ultimately helps us to better understand the comet's origin. And almost simultaneously, astronomers at the European Southern Observatory conducted a separate study that measured heat signatures from Borisov's comet. With the combination of data from VLT and the Atacama Large Millimeter Submillimeter Array, or ALMA for short, the team discovered millimeter-sized grains rich in carbon monoxide and water being expelled from the comet. These findings suggest two things. Number one, that Borisov comes from an extremely cold environment. And number two, that it was more of a traveler than a stationary rock, beginning in the inner area of a star system before being pushed outward and collecting ice along its journey. Borisov likely moved further and further away until finally resting in an area deep within its star system and undisturbed by either heat or radiation. Astronomers believe the process of Borisov exchanging materials was influenced by giant planets in the early universe through a process called gravitational stirring. And this same process is thought to have contributed to the formation of our solar system. Unfortunately for researchers, Borisov has made its exit out of our solar system, and they won't be able to make any new observations of the comet. These studies have left the astronomy community with many questions. Is the star system Borisov hails from really so different from our own? And how much has the comet actually changed since creation? And we'll hopefully get closer to answering some of these questions as teams across the world are looking to study comets more closely and learn about the star systems they originally come from. The Vera C. Rubin Observatory is set to open in late 2022 and will hopefully detect interstellar objects while surveying the sky. And the European Space Agency aims to launch its Comet Interceptor mission in 2029 to pursue traveling objects as they move through our solar system, hoping to give us an even closer look at visitors from distant galaxies. Including Borisov, did you know that humans have only seen two objects from outside our solar system? The first discovered in 2017, Oumuamua, which is the flat rock thought by many to be an alien spacecraft. To learn more about the first interstellar comet, check out this episode on Oumuamua here. Make sure to subscribe, and thanks for watching.